Sorry, I'm not really sure why the camera stopped recording. But as I was saying at the end of the last video, to get the cumulative frequency for the second row, you add the column above it to the percentage of the next row. So that's, in this case, 33.3 plus 55.6. That's going to give us our 88.9%. Another way that we can do that is to add these two frequencies together, which 150 plus 250 equals 400. And we would divide that number by the total. That's going to give us the exact same number here. 400 divided by 450 is 88.9%. Okay, so what this is telling us is that the cumulative percentage is just the total amount of people up to that row divided by the total amount of people in the whole data set, right? And that's what adding these two numbers is doing. So by adding the next two, 88.9 plus 5.6, we're going to get the cumulative percentage for upper middle class people. So 5.6 plus 88.9 is 94.5%. Then, to find the cumulative percentage for the final category, which is upper class, we would take 94.5 and add it to 5.6. That gives us 100.1%. The last row of your cumulative percent table is always going to be 100. Okay, in this case, we're 100.1, and sometimes you're going to be 99.9. And that's okay. The reason you're getting off by that 0.1% is because we're rounding during the process. If we weren't rounding throughout, it would always be exactly 100. But this rounding error is totally fine. It's just because we're rounding for ease of interpretation. All right, so here, the last column, the last row of your cumulative percentage is always going to be 100. Okay? And remember, like I taught you, to find the median when you have a cumulative percentage table, all you need to do is find the value of cumulative percentage that first passes 50%. Because the median is 50% of the way through the data set. So let's see here. Does working class pass 50%? No, it's 33.3. So we go to the next row. Does lower middle class pass 50%? Yes, it does, right? Because 88.9 passes 50%. So this is where we draw the line, and that means that our median is lower middle. Okay? Now, the last measure of central tendency is the mean. But as we know, we cannot find the mean for ordinal data because the data aren't numerical. You can only find the mean for interval ratio data because the mean requires numerical data. Okay? It requires numerical data. So, now that we've found the mode and the median for an ordinal variable in a frequency table, we're going to move on to interval ratio data. So we're going to get rid of all of this. And we're going to make a new table for interval ratio. And this time we're going to do average number of hours slept. Okay? We're going to start with, let's see, the lowest hours of sleep by people in our data set was 4. And then we had 5 hours of sleep, 6 hours of sleep, 7 hours of sleep, 8 hours of sleep, 9 hours of sleep, and 10 hours of sleep. Okay? And here we have our frequency. So how many people in our sample slept for only 4 hours? 12 people. Then 5 hours, only 3 people. 6 hours, we had 32 people. 7 hours, just the one. 8 hours of sleep, we had 56 people. Okay, 9 hours of sleep, we had 22 people. And 10 hours of sleep, we had 10 people. Okay, so this is our frequency distribution for our interval ratio data of number of hours slept. We know that this data is interval ratio because 1, it's numerical, right? So number 1, all of the values are numerical. Number 2, we can put them in order, ascending or descending, right? So in this case, we're in ascending order. 4 hours of sleep is less than 5, which is less than 6, 7, 8, 9, 10, etc. Right? We know that these always go in this order. So number 2, we can put them in order. And number 3, the final thing you need in order to be interval ratio is we can perform simple math on the numbers, right? We can subtract 10 hours of sleep and 6 hours of sleep. And the difference is 4 hours of sleep. Exactly. We know exactly the difference between somebody who gets this much sleep and this much sleep, right? And the difference between somebody who has 6 hours of sleep and 5 hours of sleep is exactly the same as the difference between somebody who gets 9 hours of sleep and 8 hours of sleep. That's 1 hour, right? The difference between each of these categories is exactly the same, and we can perform this simple math to prove it. So that's the 3 things you need. It needs to be numerical data, you need to be able to put them in order, and you need to be able to perform simple math. You need to be able to subtract these values from each other, and they need to be meaningful, right? There is a meaningful difference between 9 and 10, and there is a meaningful difference between 6 and 10, right? In the first case, it was 1 hour of sleep, and in the second case, it is 4 hours of sleep. So let's find our measures of central tendency. The first is the mode. Finding the mode is easy. Which value occurs the most frequently? 8, right? 56 is the highest frequency, so our mode is 8 hours of sleep. To find the median, we can do what we did in the last example with the ordinal data and make our cumulative percent distribution, but there's another way we can do it. Remember, we had that formula from before. To find the position of the median, you do n plus 1 divided by 2. So we need to find our n. Remember, n equals total people, or countries, or observations, or data points, but in this case, it's people. And we find that by adding up all the frequencies, okay? So we have 12 plus 3 plus 32 plus 1 plus 56 plus 22 plus 10. And that gives us a total of 136 people. Okay,